Okay. So then get this recorded for everybody that's going to miss it today. Okay, so what we're going to be looking at is chemical reactions. And what we've been looking at to this point has been just the compounds, okay? And like, you know, they could be beginning compounds, they could be the stuff that you end with, but that's what we've been looking at. Now we're going to take those compounds and we're going to react them with other compounds to form new things, okay? So it's a process of where we're rearranging substances. It's also known as chemical changes. And I think that's one of the blanks you have to fill in on your notes, okay? What evidence do we have of chemical reactions? Now, not all of these are evidence. Sometimes, you know, that we end up getting these things and they're not actually chemical reactions. But typically, when you have this happen, you get a temperature change. You can form heat. I mean, think about like lighting a match, for example. You know, that is a chemical change. And then the last one here is precipitate formed. Let's see if I can find an example of that on, yeah, here's a good one. So once you get these written down, I'll show you this and talk about it. Anybody still writing? All right, so a precipitate formed, what you do is you start out with two clear liquids and you mix them together. And when they mix together, they actually form a solid. So they're going to take that clear liquid that's coming down here and it's going to go into this clear liquid and then see how that becomes cloudy. And there's actually a color change here. But that is a precipitate. Okay. And is this the one where they centrifuge it? And you can see it later. You can see there that if you let it sit for a long period of time, you're able to see that. So here's one. Let me see if they've got, so there's the two clear liquids and they mix them together. You end up with this. And a lot of times they'll let it settle. Yeah, so here they let it settle and you can see that yellow substance is at the bottom. So that is called a precipitate, and that is a classic example of chemical reaction, evidence for a chemical reaction. And we'll actually be using those when we get into the double replacement reactions to determine if a reaction actually occurred or not. Gas bubbles, odor, color change, so all different kinds of things that indicate that chemical reaction has occurred. We have on the left side of our equation, we have reactants, and then we have products on the right side. And then we use an arrow to separate those. And that arrow is read as reactant 1 plus reactant 2 yields product 1 plus product 2. And sometimes they'll say reacts to produce, but commonly yield is what it is. And if you think about like farming, they talk about yields, what you crop yields and that sort of thing. So yield means more than just slow down and look for oncoming traffic, okay? Yield here means that you're getting that amount. Sometimes when you read a recipe, it'll say it yields 24 cookies, okay? So that's another meaning for yield. It has a couple. Remember your Brinkelhoffs. We talked about these before semester break. There are, when you're taking a test in here, there's a ceiling tile up here, and then there's two on that side of the room that remind you of your Brinkelhoffs. So if you ever forget them, you can always use that as a visual aid. When we write these, when they're alone, remember we always have that 2, like O2 or H2. We always have that written down. Indication of phase is important, especially when we are doing the double replacement reactions. S is a solid, L is a liquid. AQ means that it's mixed with water. Aqueous is what that stands for. And if you think about like aquatic center, anything like that, Aqua Jays we have here in Rock County, you know, for the ski team, and then G for gas. So chemical reactions are going to show that matter is conserved. That means that we haven't lost anything or gained something randomly. Conservation of mass law says that if you start with 50 grams, you got to end with 50 grams. You can't just create matter out of nowhere. And a balanced chemical equation is going to show that. So to balance an equation, you have to find the right coefficients. And I'll show you what a coefficient is here in just a minute. A coefficient is the number written in front, that should be front of, I don't know, I must have messed that up a little bit, sorry. In front of a reactant or product. The coefficients are usually whole numbers. They're going to be whole numbers for you this year. Once you get into AP, then we can do fractions, but right now we're doing whole numbers always. Coefficients in a balanced chemical equation describe the lowest whole number ratio of reactants and products. So first of all, you're going to start by writing a skeleton equation. Then you're going to count the atoms of each element and in the reactants and then the products. And then we're going to change the coefficients to make the numbers of the atoms balance out. And it should always be written in the lowest possible ratio. Now, here are some hints, and I will use these over and over with you. Count polyatomic ions as one unit. Don't separate them out into their individual atoms. If it's the same polyatomic ion on the reactant and the same on the product, keep it together as a polyatomic ion. It'll just make it easier. I'll show you what I mean in a minute. Leave uncombined elements to the last. Hydrocarbons need to be doubled often. And then if even and odd, double the odd. And then water sometimes can be written as HOH to help you because that's a polyatomic ion, hydroxide. All right, so let's get started with these. So step one, when we do these, is we are going to divide our reactants from our products. Then we do an inventory. So I'm going to write down HG and O. And whatever order it appears in on this side, no matter what it looks like over here, keep it in the same order. Now, this happens to be in the same order, but sometimes they're scrambled around. And if you keep them in the same order across from each other, it makes it easier for you to compare the numbers. Then we're going to do an inventory. HG, I have one of these, and I have one O. Over here, I have one of these, but I have two oxygen. Okay, we need all of these numbers to match, and right now they don't. So we cannot change subscripts here. You cannot do that. The only thing you can do at this point, once you've got everything written down in your equation, the only thing you can do is change coefficients. So I need 2 oxygen over here, so I'm going to put a 2 here. But that just doesn't change the mercury, the oxygen. It also changes the mercury. So now I've got 2 mercury and I have 2 oxygen. Well, over here that matches, but now this doesn't. So what I do is I put a 2 in front of here, and now it balances. Okay, so it's kind of got, you got to do this back and forth kind of game to get this stuff to work out. These inventories down here are like training wheels. If you can balance this without writing these out, I'm okay with that. Okay, but if you need to do this all the way through AP, I'm okay with that as well. Okay, like I said, they're training wheels. Whenever you're ready to take them off, go. And sometimes you need training wheels, and sometimes I still use them once in a while. So some bigger equations or stuff that I'm having trouble with, I still go back and do this. And how many, you don't want to know how many years I've been balancing an equation. All right, so here we go. I have over here, I have a polyatomic ion. And if I rewrite this as HOH, I have that same polyatomic ion over here. So I've got my sodium, I've got my hydroxide, I have my hydrogen, and this is a polyatomic ion that's unchanged on both sides. I'm going to keep that together. Then I'm going to go, now this is scrambled around, but I'm going to write it in the same order over here because it's easier for my brain to keep track of everything if they're on the same line. So now I'm going to do my inventory. I've got one Na, I've got one OH, I have two hydrogens, and I have one sulfate ion. Over here, I've got two sodiums. I have one sulfate. Because I have rewritten this, don't look down here because that's going to confuse you. Because I've rewritten this like this, I've got one OH and one hydrogen. See what I'm saying? All right. Now we need to get this to balance. Well, I need two sodiums. So I'm going to go over here. Oops, I've already got two there. I need to go over to this side. I've got two here, but that affects my sodium and it affects my hydroxide. So now those are up to two. But now my hydroxide and my hydrogens are off. So I'm going to go over here and put a 2 here. And now that takes that up to 2. And it takes that up to 2. And I've got it balanced. You can split these, these things out where you have a sulfur and you have your oxygens and you have your, but this balance is like a breeze compared to doing that. Try doing it the other way sometime and see what I'm saying. Or just stick with my method and make life easier. I did not discover that method, unfortunately, until I started teaching chemistry. So I went most of my life without knowing that. And then I realized that and I was like, oh my God, it's a miracle. All right, let's try another one. Any questions about these? You guys are always so quiet. All right, so then here, we're going to break these out. I have a polyatomic ion here, and I have a polyatomic ion here. They are unchanged on both sides. So I've got Pb, I have NO3, I have a potassium, and I have a chromate. Again, I'm going to write them in the same order. And then I'm going to do my inventory. So take a second, see if you can do your inventory on these. Looks like we might get some snow the next day or so. All right, so let's check your inventories. Over here, I've got one. Oops, because I switched slides. Or I switched my monitors. So over here, I've got one. Here, I have two of these because it's in the parentheses. I've got two nitrates. I have two potassiums, and I have one chromate. Over here, everything is a 1. All right. So now we need to get this to balance. If I put a 2 here, that brings that up to a 2 and that up to a 2, and now I'm balanced. Easy? All right, let's try this one. So your inventory, again, my SO4 is the same. If I rewrite this guy as HOH, okay, so do your inventories now. Get your inventories written down for these and see if you can balance it. 3 to 5 inches. That's not much. 3 to 5 inches. All right, so, oh, yeah, it's going to get grumpy on me. How's your inventories looking there? All right, see if you can balance it now that you got your inventories written down. Yep. You end up needing coefficients on 3 of the 4 of these. Give you that as a hint. They're kind of like little mini puzzles. They're kind of fun in a way. I know, I have a more sense of fun, don't I? I would strongly suggest that you balance equations in pencil as well, especially until you're used to doing these. All right, so let's look at this guy. We've got 2 hydrogens over here. I'm not going to start with him. I'm actually going to start with this guy, okay? So I've got 3 sulfates. I want 3 sulfates over here, so I'm going to put a 3 here. So that gives me then 6 hydrogen and 3 sulfate. All right? See if you can balance it now if you were struggling with it. Take another minute and see if you can, if that got you to the point where you can pull this off. Then I'm going to need, this is going to flip on me. There we go. Then I'm going to need 2 here to get my bromine, boron balanced. But that also affects my OH. That takes that to a 6. So now I've got these 2 taken care of. I need to get these 2 to a 6 each. So if I put a 6 here, then that's going to get me a 6 and a 6 here, and now I've got it balanced. Okay? So once we're done with that, we're going to start going through and looking at these reaction types. And this is essentially what I wanted you to do for your drawing that I had to do on Thursday. But I wanted you to do it with people or items or something like that. But this is the idea where we take for this first type, we take two separate things, and we bring them together and we make one thing. And that's called synthesis. Here we have two things that are together and we break them apart. So that's decomposition. This one, we end up having two things together and one thing by itself. So you have a compound, and I call these, and this is not a scientific term, this is a lippy term. I call this a singleton. Okay, it's off by itself. So we have a compound and one of these singletons. And that singleton bumps one of these things from the compound and makes it go by itself. So this is called single replacement. And if we do that down here, where these trade spots, that's called double replacement. All right, here is another example of that. So this is kind of what I wanted you guys to try to do with your drawings. Combine two or more things together into one compound. So we had a cat and a fish, and the kitty ate the fish, and now it's happy. Okay, so synthesis. How does that look in a chemical reaction? Well, we have two single items, and we'll put them together in one item. Okay. Decomposition then. We're taking one item together, and decomposition is pretty easy to recognize because you always start out with one reactant. So if you have one reactant, you should not even have to think about it. The only option is that that thing decomposes because you don't have anything to synthesize with it to bring together. You don't have anything to replace within it. So if you have a single item, it has to be decomposition. So here we had an egg with a chick in it, and here we've got the eggshell and the chick out. Then we've got single replacement. How does that look in our equation? Well, we've got a singleton. Like I said, you've got a single item here and a compound. And remember, if we write this as HOH, the lithium is going to come in and replace that hydrogen to make lithium hydroxide. Here the dog has a bone. Here it has a steak off to the side. Drops the bone for the steak. Because who would not do that, right? Yeah, especially a dog. All right, and then we've got combustion reactions can be these other ones as well. Okay, so here we have but the idea behind combustion is that it always, one of the reactants is oxygen. That is a combustion reaction. That is the definition of a combustion reaction. So cellular respiration within your cells, all of your cells that's going on right now, it requires oxygen, right? It's one of the reactants. It's a combustion reaction. You're not poof, but that is technically a combustion reaction. And then double replacement is the last type. So we only talk about 5 in here. And this one, we have the bunny has the steak, the dog has the carrot, and then they swap here. And now the dog has the steak and the bunny has the carrot, and everybody's happy. How that looks in a chemical reaction, we have calcium with hydroxide and hydrogen with chlorine. Well, the calcium switches partners, so the calcium's now with the chlorine over here, and that hydrogen is with the hydroxide. Remember, we can write this as HOH. So those are your 5 different types of reactions. So for tonight, and I mean it, look at me, James. For tonight, you are going to be working on this worksheet. So you have 9.3 in your packet. You're going to tell me what type of reaction it is. Okay. And like number 2, this is a combustion reaction, but it's also what? Synthesis. Yeah. So either one of those answers would be acceptable for this. Good job. Okay. So you need to tell me what kind it is, and then you need to balance the equation as well. So I want that done for, I will see you guys back on Wednesday, and then you're going to get, tomorrow I'm going to go through and introduce a couple of these specifically. And at that point, you just get the beginning of the equation and you have to tell me what the products are. And you're going to need a sheet to do that with. So I'm going to give that to you today, but I don't want you to actually use it until tomorrow's video, okay? And the video will be posted after during third hour tomorrow. Because I'll do first hour's video and then I'll post it during third hour for you. So just put this sheet away for now. We'll use it tomorrow. But since you won't be here tomorrow, I can't give it to you tomorrow. So I'll give it to you today. All right, there you go. And for those of you who did not get 9-2 done, if you want to get that done now that hopefully you understand this stuff a little bit better, it was due, I think I gave you today was the deadline for it. So you get 2 days beyond that. So if you don't have it done by Wednesday, I'm not giving you credit for it. And I can stop recording.